Hey everyone, and welcome back to the Data Crunch podcast. I'm Vadym, Growth Marketing Manager here at OWAX, and today we're diving into a topic that impacts every data team: data modeling. If you've ever been stuck cleaning messy, inconsistent data, spending hours trying to fix reports that don't match, or struggling to get one version of the truth, you are not alone. The pain, it usually traces back to poor data modeling, or no model at all. To help us unpack this properly, I've got our head of product, Ruslan, here with me. Hey Ruslan, ready to model some meaning into a topic?
Hey Vadym, absolutely. Data modeling is one of those, behind the scenes processes that people overlook until everything starts falling apart. Without a structured model, even with the best tools, can lead to the worst decisions. But once you have a solid foundation, things just click, reports are accurate, systems talk to each other, and business users trust the data they see.
That's awesome. So before we get into what data modeling actually is and how to do it well, let's make sure everyone stays in the loop. If you're watching this on YouTube, be sure to hit that subscribe button and leave us a comment below. We'd love to hear your biggest data struggles and wins sharing with us. And if you're listening to us on Spotify, Apple Podcasts, or anywhere else, don't forget to subscribe as well and turn on your notifications. New episodes drop every Thursday, and we're just getting started with all the practical topics in analytics. So let's get into it. Ruslan, how do you define data modeling?
Well, let's keep it simple. Data modeling is like creating the blueprint of how your data is organized. Just like you wouldn't build a house without, an architectural plan, you shouldn't build dashboards or databases without a data model. It helps you define which objects are important, like customers, products, or transactions, and how they relate to one another. It reduces duplication, improves data quality, and ultimately gives you faster, more accurate reports.
Great. So I see it's like a building the roads before you start driving a car. You need the right structure to get where you're going. Okay, so what would you say are the core benefits of having a solid data model in place?
A great analogy, actually. Here is why it matters. First, data becomes usable. It's clean, organized, and structured logically. The second one, fewer reporting errors. You avoid duplicates and data mismatches. The third one, decision making improves because the insights are reliable. The fourth one, better collaboration. Everyone's working off their same definition. It's very important. And the last but not least, even things like cloud migrations and external communication become easier when your data model is clearly documented. It's not just for analysts. It benefits for the entire business.
Okay, so as I understand, without a solid data model, you get duplicated data, inconsistent metrics, and endless hours of manually fixing broken reports. As I see, for business teams, it means constantly second-guessing your numbers. And that's the last thing you want to do, right? So let's get into the anatomy of the data model. What are the core building blocks of a data model?
Well, I'd say there are three main parts: entities, attributes, and relationships. So the entities are your key objects, like customer, order, or product. Attributes describe these objects: name, price, quantity, etc. And their relationships define how those entities connect, like a customer placing multiple orders. Understanding how these pieces work together is the first step toward building a data model that reflects how your business actually operates.
Now, not all data models are the same, right? there are types of models for different stages and use cases. Could you walk us through those, please?
Yeah, definitely. There are three main types. So the first one, conceptual data models. This is kind of high-level overview of your business entities and their relationships. It's not technical. It's more about, aligning data with business goals. The second one, logical data models. More detailed, it defines table structures, attributes, and relationships, but still independent of specific tech. And the third one, physical data models. These are database-ready blueprints. You define exact table structures, data types, and indexing strategies and some constraints. It's kind of like going from a pencil sketch to a detailed floor plan to actual construction blueprints.
Yeah, that makes sense. And at OX, we always talk about trusted data. So how does data modeling support that?
Exactly. Trusted data is equal well-modeled data. When your data model aligns with your business logic, like how you define a customer or what count as a conversion, you get consistent numbers across all your reports. Everyone speaks the same language. It's mega important. No more debates like my dashboard say this, but finance say that. That consistency builds trust in the data, and that's priceless.
Yes, for sure. That's a really helpful way to look at it. Let's talk techniques. There are a lot of ways to model data. What are some of the most common ones?
Well, you can split techniques into traditional and modern categories. Let's start from traditional. Traditional methods include hierarchical modeling. It's like an org chart, strict tree structure. Relational modeling, tables with primary and foreign keys, great for a transactional system actually. Network modeling, more flexible than hierarchy, supports very complex relationships. And the last one in this category, I'd say object-oriented modeling. Think of each data object as a mini software object, very useful in development environments. And let's back to modern techniques to this category. Modern techniques focus more on analytics and flexibility. And in this category, the first one, dimensional modeling. Star or snowflake schemas, ideal for BI tools. Entity relationship or ER modeling, great for visualization how objects relate each other. Data vault scales well, separates raw data from business logic. And the last one in this category, graph modeling, perfect for, pretty complex interconnected systems like social networks or recommendation engines and so on.
I see. So there's a lot to choose from. So how do you know which technique to use?
It depends. It depends on your goals. If you're optimizing for analytics, let's say, choose dimensional modeling. If you want flexibility and scale, choose data vault or graph modeling. If you're working with apps and code, object-oriented might be your thing. But honestly, even Google Sheets can be your modeling playground if you structure it, right. It's not about using the fanciest tool, it's about matching the model to the business need.
All right, I love that. Let's go deeper into the process. How do you actually build a data model?
I'd say there are several clear steps. First, identify key entities. Start with what matters: customers, orders, etc. Second one, define attributes. What details do you need about each entity? The third one, Establish relationships. How are these entities connected? The fourth one, map attributes to entities. Make sure everything is organized logically. The fifth one, assign keys. Use primary and foreign keys to maintain integrity. And the last one, refine. Continuously adjust based on feedback and changing business needs. It's not one and done thing. Your model should evolve as your business evolves.
Yeah, I like that. Now that there are a bunch of tools out there for data modeling, what are some of the top ones you can name?
Oh, there are a lot of them. So here are the few. ER or Studio, Advanced Modeling and Version Control. IBM InfoSphere, great for enterprise teams and collaboration. Oracle SQL Developer Data Modeler, ideal for Oracle environments. SAP Power Designers, handle structured and unstructured data at scale. DBT, Holistic, Lucid Charts, and so on. There are a lot of great tools. And of course, OWASP BI is what we use and recommend. With OWASP BI, you can apply pre-built data modeling templates or start from scratch. Business users and analysts can collaborate on trusted data models and report in their favorite places like spreadsheets. These tools, super user-friendly and convenient, so even junior analysts can jump right in. Plus, it's great for teamwork, even in a big companies with tons of analysts and business users.
So it's not just about modeling, it's about making that model usable by the business. And that brings us to something I recently heard you say, Ruslan: data is only powerful when it's accessible.
Exactly, 100%. You can build the best data pipeline in the world, but if your marketing or finance teams can't use it to answer questions, it's worthless. That's why we built semantic layers and conversational UI into OWASP BI, so business users can interact with the model naturally and generate their own reports with confidence.
Great. Let's close with some best practices. What should our listeners keep in mind when building or updating their data models?
Well, here is a quick checklist. Align with business goals. Always model with outcomes in mind. Document everything. Names, relationships, rules. Write it down. Pick the right modeling approach. Match structure to need. Use consistent naming. Avoid confusions across teams. Keep it simple but scalable. Build what you need now with room to grow. Plan for flexibility. Your model should evolve with your business. And the last one, integrate governance and security early. Privacy isn't an afterthought.
Wow, that was a crash course in data modeling, Ruslan. And for those of you who are listening, if you're building reports, struggling with inconsistent metrics, or just want to upgrade your analytics game, check out OWASP BI at owax.com. Model your data, visualize it in spreadsheets, and start making faster, smarter decisions without waiting on engineers. And don't forget to subscribe to the Data Crunch podcast. New episodes drop every Thursday, and we've got a lot more insights coming your way.
Thanks, Vadym, and thanks to everyone listening. Stay curious, stay structured, and we'll see you next time.